Hi everyone, Dmitry Khan and Vector Podcast is here, and we are in Berlin at the marvelous great conference called Berlin Buzzwords. And I have the honor to record together with Doug Turnbull and Trey Grainger, the two stars in the search world. Can you imagine to meet them in one place? That's super amazing. And I'm just hi to you, both of you. How do you feel about the conference? How it's going?
Oh, it's great. It's great to see people we haven't seen in a while. It's always a great place to connect with colleagues and, have great conversations.
Yeah. Been coming to Buzzwords for a couple of years. It's a great conference. And it's not just the one conference. It's like a whole week now, Berlin Search Week. So it's Berlin Buzzwords. Mices is tomorrow. Doug's going to be speaking there. There's a Future of Search conference on Thursday. I'm going to be speaking there. And there's lots of meetups. The Women of Search have a meetup. Quadrant's got a meetup. There's lots of great things going on this week. So good time to be here.
Yeah, that's great. And it's also great to meet you here. Obviously, you both traveled from afar, from the States to be here. Like yesterday, we had a panel together with Charlie Hall about, whether AI, obsoletes search in some sense, like, and maybe us as software engineers. What's your take on this? How do you feel about it?
I think that AI is extremely dependent on search, actually. So we all know AI hallucinates. And really, I think when ChatGPT got useful is when it was able to do searches. And even with things like, you're seeing things like AI use file system tools to do search. What's interesting about that is when you look at the research of that, yeah, it works for like 100,000 documents or something like this. It works for like a small scale, basically the upper limits of a code base. And the other thing about that, but when you get that past that like 100,000 web documents or so, it really breaks down, stops working. The other thing about that is one of the tricks I think that especially coding agents have done is coding agents really force you to organize your data. And if you've worked in search for a long time, one funny thing is we're always begging people to do a better job of organizing your data. And when you work with a coding agent, you're writing documents so the agent will discover it. You're putting in all these breadcrumbs of why it might be useful and all these things. And I just know on so many search projects, nobody actually does that with like your e-commerce. People might SEO their e-commerce and whatnot. But I think the interesting thing, one side effect of AI is it's forcing people to focus on optimizing their findability of their content and usability of their content, which means that search doesn't have to be as rigorous or smart to find those nuggets of information.
Mm-hmm. The question is search going away?
Yeah, like do we even need search, like what Doug just mentioned? Like you can just throw your markdown files on your file system at an agent and just get the job done. Like why do we need search engines?
Yeah. I think search is becoming way more important than it used to be. And like Doug said, I think he said the time when ChatGPT became the most useful was when it got search. Yeah. I think what we've essentially done is we've gone from a world in which we build search engines that you put keywords into to find things and then analyze the results. And we've essentially just now wrapped them, like treated them like an API and wrapped them with LLMs. And so search and access to the data, we just call that context. I need context from my LLM to be able to, process, to interpret. Well, where do you get context from? You go find it and you search. One of the things I like to say, thinking about Google, is a search engine is at a very high level just a giant cache. So Google is just a cache of the internet. Why do we use Google? Because I don't want to go scan through billions and billions of pages to find what I'm looking for. I want to be able to put something in and quickly find a cache of hit the cache and find the documents that I'm looking for. And all search engines are the same way. In theory, we don't need search. A lot of people now are talking about using grep with agents, right? Let's just get rid of search and just grep through everything. That works totally fine on thousands of documents when you can't actually scan through all of them. But if you go back to the 2010s and think of Hadoop, like our whole paradigm with Hadoop was I have a massive amount of data and I'm just going to literally parse through all of the data in parallel to find what I'm looking for. And you can absolutely do that, but it's not efficient. It takes a lot of processing. And so having something like a search engine where we can very quickly go and find the context we need, ranked by relevance, and then give that to the LLM becomes ever more crucial.
Right.
And so it's actually a really exciting time to be in search, because pretty much every AI engineer is building systems. They're realizing they need RAG, and then they're realizing that the context coming back is not good unless they highly optimize the retrieval. And Doug and I are getting a lot more work and a lot more interest in teaching courses and writing books and all of that. And it's just growing like crazy.
Yeah, I want to ask you as well about the course, but before that, like, there is this thing that there is a lot of like search engines already deployed out there that have been there before the LLM boom and all that, right? And they pretty much run on like standard keyword, based retrieval. And just yesterday after the panel, someone approached me and asked, like, for us to add, a vector, dimension gonna cost a fortune. So like, how should we reason about this? Should we even care? Are there other techniques that we can apply and kind of plug ourselves into this new RAG and agentic stuff? Like, what do we answer to people like this?
I talk to teams about this a lot. And when people take on, it's very often because we work in search that we'll go to a search team or that has an existing relatively mature and relatively functional search system. And maybe it's a keyword search system mostly. And the anti-pattern I see is they immediately assume that they need to chunk all of their content, embed all of their content. And it's really easy to take a search engine of, say, 100 million documents or tens of millions of documents and easily end up with 10 billion chunks and then 10 billion vectors. And that becomes this massive scaling problem. And so one thing I've seen teams do is they will go down the path of building out these really sophisticated, very dedicated RAG systems without even knowing if there's any product value. Because, we all know there's that statistic, 95% of AI projects fail. And so you really need to have some intermediate steps to figure out whether or not there's actually value in this product. And so there are a lot of things that you can do just with your existing search system to pull back context. And one thing I like to remind people of is when ChatGPT, for example, is searching, it's literally just using Bing or something, but it's literally using a web search engine. It's using an existing index, and it might be able to parse through that more intelligently. But you can do things like pull back that size of content, zero in on the snippets that are actually relevant to answering the question, allow the agent to look around the document for even more context, without necessarily even chunking. And then if you do need to chunk, there might be good reasons to chunk. You don't necessarily have to jump right away to vector search. You could chunk and just do BM25, your typical lexical search. Not necessarily, like maybe vector search will be a lot better, but you still need that to not invest so much in your technology before you get some kind of product signal that this is a good direction.
Interesting. Trey, what about you?
Yeah, and I think to the question of, hey, we've got so much data, we can't even put the vectors in. There are a lot of optimization techniques. Like, for example, many kinds of quantization and representation learning, where you can take the full size vectors, you can reduce them down to even a single bit per dimension, and you can index that data for a first initial pass at search, and then you can keep another representation of the data on disk only and use it for re-ranking and optimization. So there's a lot of engineering tricks that especially people who've not worked in search before, maybe they're AI engineers, they just sort of use what out of the box examples they may not know about, but there's so many different ways to integrate vector search along with your keyword search. There's emerging techniques like late interaction, we'll probably talk about in a bit, that also allow you to do things that don't require these like crazy chunking exercises where you're literally breaking the document into thousands of pieces, where if you just model the domain and model the data appropriately, you can get a lot of intelligence and a lot better relevance on your search and finding better context for your AI use cases. So there's a lot of tricks of the trade, but it's not a lost cause. There's lots of ways to approach it.
Absolutely. So my take on this was that, which I shared on stage, not on stage, after the presentation, is that basically you can compute vectors on your results and on your query and then run the similarity search. And actually that does happen to pull some of the more interesting hits to the top. So it's kind of like a cheaper way to dip your toes in the vector space and without like overpaying, right? Without upfront investment. Oh, that's really great.
Yeah, I would say yes. Some people have only keyword search or only vector search. Most organizations we work with at least now do some form of hybrid search. And there's basic ways of just sort of running them independently and combining them together. Algorithms like reciprocal rank fusion. But there's a lot more interesting ways that you can combine results and prioritize some of the, semantic results from the vector search or the lexical results or other ways of doing semantic search beyond just using dense vectors. So it really depends on the use case and what you're trying to accomplish. But there's lots of ways, and especially if you get into query understanding and not just throwing keywords at a search engine and just throwing a vector at a search engine and hoping the math magically bubbles the best results to the top. If you really get into modeling and understanding documents and queries in the domain, there's a lot more nuance and intricate stuff that you could do.
Yeah, awesome. And I know like you guys are launching the course in July to talk more about this and not only talk, to actually practice, hands-on. Can you talk a bit more? When does it launch? What's the course about? And like, does everyone can everyone subscribe? And basically, what are the topics that are covered there?
Yeah, so we I think you said, we wrote a book called AI Powered Search, which Trey has. And the great thing about AI Powered Search, a lot of the concepts in it are very timeless, and they're gonna keep applying for search teams. But the field keeps evolving. We can't infinitely add chapters to the book, obviously. And more than that, like, it's often useful for people to just work with us directly and get that hands-on experience with these concepts, be able to talk to us, be able to ask us questions. So we teach a class on AI-powered search topics, anything from classic learning to rank to query understanding to new forms of agentic search and RAG. And we really try to have a broad course that covers a lot of topics that are relevant to people in modern retrieval, going to face their actual problems. And the other thing I'll say is that, yes, it's nice to have a survey of all that. And you can get a survey of that that's, I would say, relatively academic in a lot of places. But Trey and I have combined several decades of experience leading search teams. And in doing that work, we've just seen like so many times where you have, like, let's say a learning to rank project, you're building a re-ranker model. It's so easy to spend a year doing that and not deliver any value along the way. There are ways of delivering incremental value along the way to see if you're going in the right direction. And I think that's something that requires a lot of specific industry skill to know, like, oh, I don't have to do this giant theoretical project. I can do a little bit here, ship it, do an A/B test, see if it works, adjust course gradually. And that makes all the difference when working with trying to prove out to stakeholders that your project's going to work, and trying to keep building trust as a technologist in an organization.
Yeah, absolutely.
Yeah, and so the title of the course is AI Powered Search: Modern Retrieval for Humans and Agents. And as Doug mentioned, we sort of go through a broad overview of all the major AI-powered search topics, as well as ones that we're sort of somewhat uniquely qualified to teach. And so Doug has spent years doing learning to rank, and you get to actually roll up your sleeves and get hands-on building a ranking classifier for domain-specific understanding. We talk about things like user behavioral signals and reflected intelligence. So we talk about signals boosting models, which are really important for understanding your top queries and most popular documents. We do things like collaborative filtering and personalized search. So we actually, we've got several amazing guest lecturers as well. So I'll get to the other topics in a second. But one thing we really like to do each time we teach the course is bring on guest instructors who can also extend topics to their areas of expertise. So Doug and I cover the core course material, but this time we've got, for example, Renee Kriegler from Open Source Connections, and he's going to be talking about search evaluation, so evals as well as LLM as a judge, and sort of not necessarily pitting humans against the LLM as a judge, but really like how do you put, you do both at the same time and optimize your evaluations. We have Kim Falk, the author of Practical Recommender Systems. He's going to be talking about semantic IDs and leveraging those. So his background is really in recommendations, and personalization and recommendations are a core part of what we teach in the course. And so he'll be going deep into that. We've got Amelie Chatelaine from LightOn, who is an expert in everything late interaction. And so she's really going to be going through what she's calling a field guide. So a field guide to late interaction, really walking through multi-vector representations, how late interaction works, and sort of in the field, what works and what doesn't, and how to practically deploy these systems. And then we've got Andreas Eriksson from Vespa, and he's going to be doing probably the most interesting and experimental and forward-looking session, which is about hype encoders, which is essentially creating query-specific neural nets that can be used for ranking, query understanding. That goes way beyond a lot of the standard techniques we use today. So it's still it's one of the most interesting IR papers I think of the past year, and it's very experimental. So it's not necessarily something you'll put in production yet, but we like to expose students in the course to these forward-looking ideas that might be very big and impactful in the future. And then of course we go through other things like semantic knowledge graphs and wormhole vectors, which are sort of key areas of focus for me: query understanding, semantic query understanding, agentic search. Doug teaches a whole other course on agentic search, and we integrate that into the course. So there's a lot of emerging topics, but we also focus very heavily on the fundamentals and making sure that everyone in the course has practical labs and working code and things they can take to production tomorrow. And of course, office hours every week. So we can help reinforce the concepts, answer questions people might have that apply to their particular use case or company, et cetera. So it's a whole month of courses and material and sessions. So it's pretty in depth. People tell us frequently that it's a lot of material to go through, but it's like so rewarding to learn it all.
And plus it's hands-on. I really love hands-on courses. And the cool part about what you guys do is that the topics span search engines, right? It's not like only focused on one search engine, one particular vendor. It's basically you can go and apply if you want. You can build it from scratch. I still remember using LTR libraries that Doug wrote back at AlphaSense. It helped me a lot. I built that on top of it, and then your wormhole vector idea, I also took a spin and just to try it out with open source. It was kind of fun too.
We did a lightning lesson last year, and then after that you went and actually implemented it. It was like just great to see the immediate wow, this idea is so cool, and you implement it. So we cover some of that stuff in the course as well.
This is amazing. Beyond the course, beyond the book, obviously you can augment the book with new chapters, right? Like beyond these topics, is there a specific topic in search plus AI that keeps you up at night today, that you are focusing yourself on, like something that you feel like is unsolved and needs to be solved?
I mean, I feel like everyone in 2026 is talking about agentic search, and really that comes in many different flavors, and I'm not sure anyone really agrees even what it is, but that's a lot of these new topics that Trey was talking about. So there's what we talked about earlier, where I just give some agents some dumb tools, maybe just file system and a BM25 tool, and it just figures it out. That's interesting, and people are talking about that a lot. And search engines are building things like virtual file systems to have like these agents use their files ability, because they're so good at code, ability to generate bash code to explore directory trees. And they're just like sort of going with that. And that's weird and interesting. And then on the other side, there's people who are taking maybe a more retrieval first approach to this, where they're like, well, these agents, the perspective on this whole thing, agents have been trained, these models have been trained to treat search as the place to go to get answers they don't know. They're not necessarily trained to, and they're also trained to use file system tools to explore a code base to find context. So this perspective of search is a place I go when I don't know the answer, and means that search has to, and this other perspective that search has to be really smart, and that these agents, frontier models, are reliant on intelligent search, web search in particular, which is like Google, to find current events or find some products or find like very niche things that it doesn't know about. So then they're like, we just need to build really amazing search. That's where like late interaction is coming out, where you have search engines like Hornet that are entirely focused on how agents search and not how humans search, and optimizing that. And then the final layer of this is people who are actually training models, training LLMs almost away from this idea that search is where I go to get information I don't know, and more towards I have all these broken sort of semi-working primitive search tools. Can I use them more efficiently? So people are like using reinforcement learning to train, like taking your Quen model and fine tuning it just to search, and making it smaller and more compact, but more focused on a search task. And that's also really interesting.
Yeah, great.
Yeah, there's two particular areas that I'm thinking about and focusing on, and they somewhat tie back to what Doug was saying. And I'll say it, one is query understanding and what needs to be done for query understanding. Well, actually, I'm going to start with that one. So, what Doug was just mentioning about taking tools like basic tools like BM25 and vector search and giving them to the agent and essentially having the agent do the work. It's really interesting that we found that you can actually get better results that way, but it's not surprising. The reason is we talked about grep earlier in the episode and how you can use grep to search through all of your information and find the right answer, but it's not very efficient. Likewise, if I were to give an agent a bunch of tools, BM25, vector search, etc., I can give it those tools. It can try to run a search, see that the results aren't good, reformulate the search, try to run it again, see that the results aren't good, and continue until it gets good results. And unsurprisingly, it will actually get better results than a poorly tuned search pipeline, because it just tries and tries until it gets good results. The crazy thing is that sometimes it will get better results than a well-tuned search pipeline. But the reason for that is in search historically, we've really focused on this idea of one-shotting a good result, meaning we construct this elegant, maybe complex pipeline that is designed to hit the search engine one time and bring back the best results. But the reality is you might run a search and get no results. You might run a search and get the wrong type of results. And so having this ability to have a loop and a feedback loop is something we've been missing before agents, and it's something that's really important. So that's why we're seeing a lot of focus there. My personal belief is that giving a bunch of simple tools to an agent is vastly inferior to giving an agent more intelligent tools. Because let's be honest, like if you could tell your agent to go to the search engine and it could run one search and get all the right results back and not need to loop, that's clearly a better system. And so I think that it is a useful exercise to figure out what agents can do and what the capabilities are that they add to the system, but that ultimately our job in the search world is going to be to figure out how to make the agent more efficient by not having to have it loop as many times, and use the pieces of the agent that make sense where we can, which does have to do with understanding the results and helping to formulate queries. One of the things that I'm personally focused on, so this is the other area around query understanding, is seeing what's possible to do without having to use the agent in real time. So what I mean by that is if we have our documents, we can use agents to understand the documents, to add metadata to them, to understand the attributes, to understand the taxonomy and the classifications, and to attribute our content with as much sort of pre-known information that gets indexed. And then at query time, whenever the queries come in, we can use something we talk about in the course called pseudo relevance feedback, which is taking in the query checking with our index to see what we have in the index, and using things like semantic knowledge graphs, which we teach in the course, to help interpret the meaning of the attributes that are found in the queries, to rewrite the query in such a way that matches the understanding of the content that's in the index. And so the more you can pre-understand the documents, use agents to model the understanding into the documents, and then use those at query time to interpret the meaning of the query, the better you're going to be able to do at understanding the query.
Yeah.
And at that point, you may not need the agent as much to help formulate and rewrite the query,
Right.
at least not on the initial pass. And so I'm really interested in using agents offline to improve search, so that at query time, you don't necessarily have to take the latency hit of hitting the agent over and over and over for rewriting, checking. You can potentially even have no agent and get really good agentic search because the agent has done everything offline.
Yeah.
The reality is you're never going to get it right the first time entirely, and you're still going to use an agent and have agentic search in the system. So I fully believe we're going to have this sort of hybrid model of, agents work offline to understand content. We model it into the documents. We do this pseudo relevance feedback. And then after we run that search and get the results, we have the agent assess the results and then maybe help us tweak and rewrite again. So I think it's going to be all of the above, not either or. But I think it's really interesting just to point out that most people are kind of running and focusing on one area. And the biggest area right now tends to be simple tools, give them to the agent and have the agent just loop until it gets good results. And who cares about the latency or the token costs? And I do think we'll see that pendulum swing back as we start to get more intelligent about exactly how we model what the agent does, how much it has to do, and how much we can do ahead of time. So those are some interesting areas, I think, for continued exploration. And we talk about a lot of this in the course as well, but there's a lot of innovation happening all across the information retrieval space right now. And it's going to be really interesting to see what ends up actually working and scaling.
Yeah, it's very exciting. And like, I would even reach to at the angle of, environmentally friendly way of doing these things, because if we continue to bash, search engines with like probing and basically wasting compute resource, that also is not very good for the planet either. So I think there are many forcing functions for us to keep moving the field forward. We've met a lot of, search practitioners here, obviously. It's a great way to reconnect. What would you say to the builders in the search space, right? So basically those companies that offer managed services like Vespa, OpenSearch, Solar, and all of that, quadrants, they keep innovating also beyond the infrastructure level, right? The algorithm side. What would you send as a message to this part of the community for them to keep it going and excited to push the boundary? Should they take the course, maybe read?
Oh, of course they should take the course, and they should come and speak at the course too.
Oh yeah.
I think the most successful search engineering, like the search retrieval engines, let's say, have been really good at building really good Lego pieces and not being super opinionated. So there's two kinds of systems. There is a system like Quadrant or Vespa or Elasticsearch or Solar or OpenSearch, Turbo Puffer, all the ones that I'm forgetting to mention, that just give you the Lego pieces for you to go build your solution. And those companies should continue to focus on Lego pieces and not wholly wrap solutions, because the field changes too quickly. We haven't even talked about things like agentic memory, which maybe should be using these systems. It's just changing so fast. But then there are definitely more product companies that are like, we focus on a specific use case, and they should definitely be more opinionated. But I think for the people who come and talk about building things at this company, I feel like less opinionated, more Lego pieces is probably the right way forward. And also, obviously, it's kind of taken for granted, but really robust, highly scalable. It's going to work. It's not going to have weird edge cases and that kind of thing is obviously true. Yeah.
Yeah, interesting.
Yeah, I agree with that. I think that one thing that's important to realize is that historically, what has prevented search systems from getting better and scaling has been how many search engineers you have who are able to work and solve the problem. Because it's a complicated problem to solve. And so we historically tended to go with solutions and pipelines and algorithms that could handle most of our use cases for the relative amount of effort we put in. And with agents now, we have the ability to solve some problems that used to be really hard in a much more intelligent and automated way, which is essentially raising the bar for the types of solutions that we have to bring to solve information retrieval. What that means is that search is getting more complicated. It means that also what we used to think of as search as like the index, the inverted index, and then the, vector index, the HNSW index or whatever, and, maybe some pipelines on top of it. That's no longer the scope of search anymore. Now we've got LLMs in the search engine, and we've got search, like we've got workflows and we've got loops with agents. There's a lot of pieces. We've got cross encoders as sort of a standard thing we deploy in systems now. We've got all sorts of models. We've got late interaction models. I could go through a giant list, but these are core components of a search system that has many layers of ranking and re-ranking and query formulation. And so I think it's really important for the vendors to keep in mind this notion of building blocks and the ability to plug in these different components. But I also think it's important for us to realize that the definition of what a search system is not fixed. So for example, if I'm building an AI system and there's an agent and it's running searches and getting results and then seeing if the results are good and then rewriting the query and running it again, where's the search engine? Is it one of the indexes? Yeah. Is it all of the separate indexes? Yeah. Is it the whole system, including the LLM? The notion of AI versus search are just kind of merging together. And I think it's really important that as we're building these systems, we don't lock ourselves into thinking that, a search is only this piece and AI is this piece. Because when you do that, you don't build the right types of solutions. And so I think that things like focusing on query understanding, which used to be very hard, those things are becoming easier. And I think they're opening the door for these more complicated approaches that actually work really well. And part of our job going forward is going to be figuring out how we assemble these Lego pieces, how we keep the systems flexible enough to dynamically evolve with our domains, our use cases, and our algorithms. And the vendors who are able to evolve and adapt to that and not be too rigid, I think, are going to be the ones that are going to be the most successful.
Yeah, it sounds like from how you both described it is that search continues to be the field to invest into for sure. It grew by us adding more Lego pieces there, agentic, LLMs, vectors, all of that. But we also still need to continue solve the core problem, which is completely unsolved, right? You have documents which are written in certain language, and then you have users querying these documents in the hope that they will find what they're looking for, but they don't know what to type, what exactly to say. And even with all the conversational style, we probably moved the needle a little bit, but we didn't solve it. So it feels like that's why the field continues to be exciting.
Yeah, one of the things we focus very much on in the course is mental models of how to think about search and ranking and relevance. And one of those mental models is the notion of context and what it means. And so in what we present in the course, we talk about 3 core contexts that matter for ranking. One is the content itself, what you have in your engine that can be searched on. One is the user, who's running the search, what do we know about them, what have they searched for before, and what are they looking for now? And then the domain, what did the words and phrases and connections within my domain mean? And a lot of people, when they're building search systems, only focus on one of those, right? It's usually content. I'm going to put my content in the index, and I'm going to be able to match and rank on that. But if you do that independent of having a taxonomy or attributes and knowing how things are connected, then it's not very intelligent. And if you do understand how things are connected, then you've got this notion of semantic search. But what if the user who comes to run a search is, one user is very different than another user, right? So standard example, somebody searches for a shovel. Well, is it the winter in Boston? Or is it, the summer in Florida? Those are two very different types of shovels. And understanding who your user is and what they're looking for allows you to personalize and make better recommendations. So we really have to think of the search engine as providing context to LLMs. But we also have to think of many different types of contexts in our domain, our data, and our users that we have to bring to bear on even understanding what the queries are. And so I think, anyway, the understanding of those contexts is really important.
Yeah, it's exciting to see both of you to continue to innovate in this field, but also to share so freely, right? Yeah, I mean, freely as in, yeah, you need to subscribe to the course and buy the book, but all of these are the things that will pay back like for years to come. So I really encourage everyone to take the course.
Yeah, and we also, I'll mention, Doug and I do have the course, which is like a deep dive, but we also do a lot of free content as well. So depending on when this comes out, we're probably going to be starting and in the middle of a 2-week free lightning lesson series where we're going to be diving in with a lot of other search experts, some of whom are at this conference, and really diving into topics. Like I mentioned cross encoders earlier. Radu from Vespa is going to be doing an end-to-end walkthrough of cross encoders. We've got lots of talks on agentic search, on everything kind of across the board. So definitely, come hang out with us, whether you subscribe to the course or not.
Yeah.
We'd love to chat with you, and got a lot to cover. The field's evolving very rapidly.
Yeah, I totally agree. And I think one of the things definitely coming to the class supports the work that Trey and I do, which we do a lot of public work. Like I'm known for my blog. Trey and I speak a lot, so we definitely appreciate all the support. And yeah, stay tuned. You can find us. The class is taught through Maven, which I know a lot of people might be familiar with. And you can find a lot of our content and stuff on Maven in the next couple of weeks.
Yeah, awesome. Thank you so much. I hope you want to add something.
I was just going to say, and you can go to AI Powered Search as well, aipoweredsearch.com, and you can find the course, the book, blog posts, all sorts of things like that if you want to find some more information.
Yeah, I found the AI Powered Search one nice place to kind of stay even in the awareness of what else I'm missing. And obviously reading Doug's blog, every time like a new piece, new provocative topic, like, oh, what about RAG? Is it still there or not? So keep doing what you're doing. Thank you so much. I hope you will enjoy the rest of the conference. And thank you for your time to make it here and to talk to me.
Nice to meet you. Appreciate it. Thank you.
Thanks.
Yeah, thanks, Dimitri.